Hello friends, welcome again to Math the Divine Language. Today we are going to discuss types of relation. About relation we discussed and the video is already uploaded. So today we are going to discuss about the types of relation. So the first type I have, which we call is the empty relation. So it is similar to the empty set. You know about the empty set, you may have learned in the class 11 first chapter, set theory, where what is the meaning of empty set? A set which has no element is called empty set. Okay, in the similar fashion, if there is no relation possible between two sets, we call that relation a empty set. So what if no element from set A is related with any element of set B, then we call that set to be an empty relation set. For example, if I have set A, let's say it has 3, 4, 5 as the element, it has set B, it has 19, 20, 21 as the element. We call that X belongs to A, we call that Y belongs to B. So this is set A, this is set B. So if I define a relation between these two, that Y minus X should be 70. Yes, Y minus X should be 70. So is this possible? Or I can ask the same question in a very different fashion. If I ask you, in your school, the age difference between any two students is 70. Is this possible in your school? Even if you take the extreme classes, the nursery and the 12th, it is not possible. The maximum age difference you may get is 16, 17, 18, not much more than. Yeah, not 70, it is too big, man. So it is same. So I have defined this condition, or what we call conditional relation. Relation is nothing but a condition which you make. Condition and relation is the same thing. So I define a relation between these two sets, that Y minus X should be 70. See, is it possible or not? If I take Y is equal to 21 and X equal to 3, so how much I will get? 21 minus 3. According to the relation, what it should be? Y minus X should be 70. So Y is 21, this is 3, and the here is 70. So it should be 19. This relation is say 19 should be equal to 70. Not possible. And you know, if I take any number, 70 will not come out anyway. So this type of relation is called the empty relation. Empty relation means what you will write in the set of relation you have no element. You can write this way, or you can write 5. In the relation there is no element, or you can write the same thing as a 5. Or how we write the relation? Relation is defined as the subset of Cartesian product between two sets. So that comes out to be 5. So that is something which is written in your book. It is the same thing. It is a English definition and it is a mathematical definition. It is the same thing, but this is defined in the symbol of mathematics. So this is all about empty relation. Now the second type of relation is universal relation. This relation, universal relation, is totally opposite of the previous one, that empty relation. It says what? It says no element from this set is related to any element of this set, so there is no linkage. But what this relation says, that every element from this set is linked to every element of this set. So it says every element from set A is related to every element of set B. Let's try to understand this also with this kind of number, and this will become much more clear then. So again, if I have a set A, I take the same thing, 3, 4, 5, here it is 19, 20, 21. So here again x from A, y from B. So if I define a relation y minus x is less than 70, or in other way if I say you the age difference between any two students in your school is less than 70, is it possible? See, if I take a 19-year student and a 5-year student, age difference is 40, which is less than 70. Any combination you make, which this is less than 70. So this is possible. This is possible, no? If I take y to be 19 and x to be 3, so 19 minus 3 should be less than 70. So it comes out to be 16, which is less than 70. So this is true statement. Take any combination, all of them will give you the same answer. That answer is less than 70. So you can say this is between these two elements there is some relation between these two, because the difference will give you 70, which is less than 70. Sorry, 60, which is less than 70. Difference will give you 70, less than 70. 80, less than. So you see, all of the elements are related to all elements of set B. So that is the meaning of universal set. Again, this will be what? All the elements is what? A cross B. If I define a relation between these two sets, what is the maximum element we can have? It is the Cartesian product between them. Yes, you define relation to be the Cartesian product of A cross B, and that will come out to be A cross B. Is it not? Because Cartesian product is all maximum combination you can make, and this relation is defined in such a way that all maximum combination is made. So in one sense, universal relation is also your Cartesian product. Yes, this is the thing. So you see now, these two relations are totally opposite. No element related, every element related. And one thing to note is, you should note this, or you can remember, of course you will have to remember, that if a relation is empty as well as universal, then you call that relation a trivial relation. If a relation is empty as well as universal at the same time, it's called the trivial relation. Again, it's not a big deal to remember this, but the big deal here is, can a relation be empty and universal at the same time? Can a relation have no element and have all elements at the same time? Is it possible? Think on that. It's up to you.